Hey guys, if you want to know what's on your final second semester, you're going to have to solve for the missing angles, like with quadrilaterals. That's still going to be on there. Also, we're going to skip around, so we're not going to do every single problem, but I want you guys to think carefully through these. So first of all, they want you to name for 1, 3, 4, and 6. I crossed out the other ones so we had more space. I want you to choose the best name for that parallelogram, and then I want you to find the measure of the numbered angles. And we're going to use the properties that we just learned. So first of all, I'm looking at this parallelogram and all the sides are marked congruent. So what type of parallelogram is it? That's right, it's a rhombus, because it's a parallelogram or quadrilateral with 4 sides congruent. Now, using this to our advantage, we should be able to find a couple of these very quickly. What should be the first angle that you probably can find? I would have probably said angle 3, because the measure of angle 3 is 54 degrees. Why? Because the base angles of isosceles triangles are congruent. Now, the second quickest one I would actually have solved for would be angle 2. And there's 2 different ways of thinking about it. Angle 2 is 54 degrees because I know that the diagonal bisects this angle, which means 2 and 3 are the same size. But some people were really good the other day, go, hey, that's a parallelogram, look at the Z shape, they're alternate interior angles, so they have to be congruent. I don't care which way you do it, long as you understand the process. Now, to find the measure of angle 1 or angle 4, it doesn't really matter which one. I'm going to do 4 first. I use the fact that the 3 angles of a triangle add up to 180. So the measure of angle 4, I'm just going to go 180 minus 108 because I add these 2 together, which gives me 72 degrees. Now the cool thing is 4 and 1 are congruent because they are opposite angles of a parallelogram. So the measure of angle 1 is also 72 degrees. Are you seeing how we use our past stuff with the present stuff? I hope so. Hopefully you get those down with me. Let's do number 3 because this is the best description. All right, if I have a parallelogram and I have a right angle, what type of figure is it? You should have said a rectangle right away. So that one is going to be a rectangle. And partly the reason why you'll have to show 1 is because of opposite angles being congruent and the consecutive angles being supplementary. They all end up being 90. Now, what would be the first and easiest angle to find? That's right, it's going to be angle 3 because the fact they're vertical angles. So that's 106 degrees. Now, how do I find the measure of angle 4? I'm just going to go 180 minus 106, 74 degrees. All right. Now, what am I going to do next? Well, I'm going to use the fact of the property of a rectangle. I know a rectangle's diagonals are congruent, so I have all 4 of those being the same. All of a sudden, I have an isosceles triangle I can work with. I'm going to use the fact that those 2 are the same size, so I'm going to call them x. All right, and I'm going to solve for the measure of angle 1 first. So I know the 3 add up together, so I get 2x plus 106 equals 180. Subtract 106, I get 2x equals 74. Divide by 2, x equals 37 degrees. So the measure of angle 1 is 37 degrees. Okay? Now, if that's 37 degrees, how can I find the measure of angle 2? That's right. They add up to 90. They're not the same size. I didn't say that the diagonals of a rectangle do not bisect the opposite angles unless it's a square, and that's not a square. So I do know that the measure of angle 2 can be found by just going 90 minus 37, because remember, some of the parts equal to the whole. And so then we end up getting this to be 53 degrees. All right, let's do one last one together, because 6 is going to be very similar to 4, so we're just going to stop right there. But let's go ahead and let's do number 4. All 4 sides of that parallelogram are what? Congruent. So we know again we got a rhombus on our hands. Now, what's the other thing about a rhombus? Okay, let's do a quick review. The diagonals are what? Perpendicular, and the diagonals bisect an opposite pair of angles. So we know they're going to be bisectors. So that's probably going to be very helpful information for us. Okay? So looking at that, I'm going to put my right angle in right away. Do you notice two angles you can find instantly? Yeah, angle 2 and angle 3. The measure of angle 2 equals 90 degrees. The measure of angle 3 equals 90 degrees. Excellent. Now, is there any other angle you know right away? I hope a lot of you said, yeah, I can see the measure of angle 1. Those are alternate interior angles. Well, that works. But what else do I know? I know that these 4 angles are exactly the same size because that diagonal bisected the angles. So they're all 59. So the measure of angle 4 is 59 degrees. Now, someone asked earlier, could they use the fact that those are base angles of this larger isosceles triangle? Yes, you can use that. All right, let's do one last example on here because I just don't want to take tons of time going over tons of examples, but I want to give you some good ones. Let's look at number 12, okay? And these are like examples in your book. It says HIJK is a rectangle. Find the value of x and the length of each diagonal. So for number 12, shouldn't we redraw the diagram here, or actually draw the diagram out? So of HIJK, just go in consecutive order. And they want to know the length of the diagonals. So what 2 line segments are the diagonals? HJ and IK. Well, what do you know about those 2? The diagonals of a rectangle are congruent. Don't forget that. Hopefully that's a good little reminder there. So let's go ahead and set them equal to each other. So I'm going to go 3x plus 7 is equal to 6x minus 11. Now in your homework, I'm going to tell you a couple of these are going to get fractions. Trust yourself when you plug them in. So subtract 3x, add 11 to both sides. 18 equals 3x. X is going to equal 6. Now plug it in, plug it in. You have to find the length of each diagonal. But the cool thing is you only have to plug it in one time. So HJ is going to be 3 times 3 plus 7. Oh, I think I just put that in wrong. 3 times 6. Boy, gotta pay attention. 3 times 6 plus 7, which gives you 25. What's the length of the segment IK? Exactly the same thing, 25. Check your work. You can do a quick one here. 6 times 6 is 36, minus 11 is 25. You did it right. Hopefully that gives you a jump start on your homeworks. Don't be afraid to ask questions on this, but make sure we have this done because we have a quiz the following week, and we also have this on our test coming up, and believe it or not, on the final.